Hello physics students. Today we are going to be talking about the difference between mass versus weight. And then going through two quick little example problems just to show you how to work back and forth between the two. In the last lesson we talked about the different types of forces, and so we're going to be delving into the force of gravity, which is the force of gravity versus the mass of different objects. So let's go ahead and get some definitions out of the way. Mass is the amount of stuff something has. Well, what do I mean by stuff? Well, if you said atoms or molecules, cells, that would all be reasonable, but everything is made of atoms, right? And you know, across the entire universe, we have a set number of atoms, and those atoms are our building blocks of us, the tables, everything around us. And so, the more atoms something has, the more mass it will have. And so stuff is atoms. So the amount of stuff something has. And this is typically measured in kilograms. That is the metric system, or the SI system of measurement. SI is the standard international system of measurement, and that is to keep science experiments and other things consistent so we're not having to convert all the time. Weight, however, weight is the force of gravity acting on an object. So the force that the sun, moon, etc. pulls on objects. So the earth is pulling down on all of us, and that is, well, we don't actually feel the force of the earth, and I'll get into that in a little bit, why that is. So the equation to figure out the weight of something, or the force of gravity, F-grav for short, weight is equal to m times g. And m is mass, and g is the acceleration due to gravity. All right, so the acceleration due to gravity. Some of you may have heard this before, but the acceleration due to gravity symbol is g. And in this class, we're going to just use 10 meters per second, or 10 meters per second squared. The actual unit is, or the actual acceleration due to gravity is 9.81 meters per second squared. Math is just easier in 10. We just move the decimal over, makes our lives easier. So we're just going to use 10, and that's a pretty darn good approximation. Alright folks, so we have been talking about mass versus weight and what the difference between the two of them are. And I want to just talk quickly about this topic of apparent weight and what that means. So have any of you, and think to yourselves because you're watching a video, felt heavier or lighter within a matter of seconds? And if so, when was that? What was going on when you felt heavier or lighter within just a matter of seconds? So pause the video and just take a thought and see what you can come up with. Alright, so some examples of in my life where I felt heavier or lighter within a matter of seconds is on an amusement park ride. I used to love roller coasters. I still do. I haven't been to an amusement park in years. I miss it sometimes. But going over a hill, when I'm cresting the hill on a roller coaster and you feel like you're flying out of your seat for just that second, you feel a little weightless, just floating, right? Or how about if you're going into the bottom of a turn on a roller coaster and you feel like you're getting pressed into your seat. I feel this when I've been driving, right? Driving over a little hill in your car, you kind of feel weightless for just a second. Let's see, some other examples in an elevator. So if you've ridden elevators before, which I'm sure most of you have, one time that you feel heavier or lighter is, let's say the elevator just starts going up. You might feel a little bit heavier, right, as the elevator starts going up. You feel like you're sucking into the elevator. Likewise, or conversely, when you're going up to the top of the elevator and the elevator starts slowing down, you feel a little bit weightless for a second, like you're just floating for just a second. So this is due to a phenomenon called apparent weight, and it happens all the time. And the reason being is that we only feel our weight, also known as the force of gravity. We just learned that. We only feel our weight because of the supporting force. Or normal force. We only feel our weight, or the force of gravity, because when gravity pulls down on us, what's the floor doing to me right now? Well, it's pushing up on me. And I actually don't feel gravity's pull on me, rather I feel the floor pushing up on me. And I know that's a little counterintuitive, but if any of you are curious or want to dig a little bit deeper into that with me, come talk to me about it. If you're flying through the material, I think this is a great topic to take a deeper look into, because it has some really cool applications, and there's some really fun physics problems that we can do with that. So I did just want to make you aware of apparent weight and what that phenomenon is and why it occurs. And maybe when we talk more specifically about Newton's second law, we can dig into this a little bit more. Thanks for watching. Have a wonderful rest of your day.